Hello everyone, in this video I'm going to show you how to design a common collector amplifier. In addition, I will also show you how to use it in other amplifier design. The common collector amplifier is not really an amplifier, but instead it is a buffer, a current driver. Now, what we can do here is we are given the name, right? I've already given the name demo underscore cc, and this will be the name of this circuit. And to start with, you need a biasing circuit. So you need to check, pick a NPN, and normally you can choose whatever. For my case, I will just choose 2N3904, and you need to add the biasing resistance. And I will make this LC to make it more understandable, because this one is going to be connected to the C terminal and ROE, and this resistor is going to be connected to the E terminal. So I will just do the connection in one go. So and this is your biasing circuit, and you need the voltage source as well. The voltage source is a DC. I will choose the AVOX. And I will choose a resistance for RC. I will use 1 kilo. And here I will temporarily use 50. Now, your biasing circuit is pretty much done, and you need an analysis to check if the quality of biasing is good enough. So you will use DC operating point analysis, and you do that. If you do that, then you just simulate. You will end up with, so there is a complaint. Error is not specified, so you need to check. Yeah, this one. So you need to put some value here. I will put 10K here, and here I will use 1K. So now it's quite okay, right? 1.2 milliamp. I presume now the biasing is done. So I will delete the DC analysis. And now you can have a signal, feed the signal here. So what you need to do is to use the capacitor and the capacitor here. And here as well. And you need probably 1 micro, yeah? In integrated circuit, you will unlikely get that much capacitance. Normally, this capacitance has to be supplied external to the integrated circuit. So now we are going to add the voltage source for AC analysis. And this is going to be, say, 100 micro. And I will also add the resistance here. Now hang on. We are not going to design a circuit for um, we are not going to design a circuit for common emitter amplifier. So what you need to do now is to delete this resistance, common collector amplifiers means the collector is ground. So we will do that, and the input is not going to be, the output is not going to be extract from the C terminal. So you will just move it. This is not correct, right? You will move it to here. So this is the right way. And remember, for common collector amplifier, the emitter current, the emitter resistor will be high. So I will make it for 1K to start with. So this is the circuit. Yeah, I will just squeeze a little bit to make the circuit more understandable. So this is the so-called common collector amplifier. It's a voltage driver. And now I'm going to put a low here. The beauty of this circuit is the current. Yeah, before doing anything, you need to do another DC analysis because the biasing circuit has been changed. So I'm going to do this. And let's track this again. So, so obviously you don't have enough current here. You have 0.1 milliamp. This is not going to be enough. There are many options you can choose. One of the options that you can choose is to raise this voltage. The main reason is this voltage here is not large enough. You know, when you have stem resistance here, then you will have a very small voltage here. So what I can do is I will raise this voltage, say 5K, and then I will simulate this again. So it's 1.9 milliamp for the purpose of common collector amplifier. 1.9 milliamp is a good value because we ultimately want large current at the output. The current going to the emitter may not be that much. Instead, we will route the current to here. So the low resistance here will be connected to here. As before, to start with, you use a large value, say 100K. So this is large enough, right? So I will label the circuit. I will label here as in, and I will label here, sorry, I will label here as out. So I need to simulate the behavior of the circuit. There will be low gain in the circuit, but the gain will be about negative, less than negative 1 dB. This is our expectation. So we will analyze the circuit. and AC analysis is what you want. And the starting frequency is 1, and the stop frequency, sorry, 1K is better. The stop frequency could be say 0.5 gig. So I will leave the SPICE command here. So I simulate the circuit. So again, we are going to we position the cursor onto the waveform window, and then right click, and then add trace, and then you find the voltage gain. Vout divided by Vin is the voltage gain. So here we go. So you can see this. The gain here is 0.12 dB. Yeah, minus 120 milli dB. So it's quite good. Quite good. Not too bad. It's almost 1. Yeah. If I display the circuit in linear scale, you will know it. So it's almost 1. Yeah, almost 1. Almost 1. So it's quite good. And the bandwidth here is also very wide. So I presume the circuit here is done. But the problem is, the circuit you have here has a biasing network here. Normally, you you don't really need a biasing circuit like this. The output of a common emitter amplifier is already biased. And the purpose of this circuit is not to have voltage gain. Instead, we want to have current gain. So in other words, if I simulate the circuit again, I will get this. We want more current to go into the output. So ultimately, we want to be able to run the circuit at to drive a very low resistance application. So in this case, I would reduce the resistance, say 100. And I will try this again. And the gain here is still very good. Slightly lower, but it's still at the right level. If I display this in log scale, then you will know this. Not too bad. It's still negative, right? Let's read it. I hope it is. Voltage output divided by input. There shouldn't be any voltage gain. This is not really, it doesn't make sense though. I end up with a voltage gain almost 1. But I think it's still, decibel. You need to display it in decibel, not it. Sorry about that. Okay, not too bad. Yeah, it's slightly larger than, slightly smaller than minus 1 dB. So it's still okay, I consider. Now, the circuit is obviously capable of driving a low resistance load, and you can further reduce the resistance at the load and see if it's still up. It's getting not quite good now, minus 7 dB. So I would say the resistance 10 ohm is too high, too small. Let's say 50 ohm. Okay, that's not too bad. Even with 50 ohm, you can still drive the circuit with that much gain. Not too bad. So this circuit is obviously usable for many other applications. So let's try one of our circuits that we have designed before. We have designed a common base circuit before, yeah, common emitter, yeah. We will drive the output. No, not this one. We will use the circuit to drive this circuit, common collector, common base. So you have a base here, but the resistance here has to be 10K. That much. You cannot uh, use a low resistance circuit here. If you use a low resistance circuit, say 50 ohm, then you will have low gain. You will have low gain. So I'm going to plot the gain of the circuit to you again here. The gain originally is close to 39 dB, but now by doing this, you will have only 4 dB. It's still good. At least there's some gain, but it's not fantastic enough. So what you would do here, uh, would do here is you use the circuit here. You use the circuit here. So you duplicate the circuit here. You don't need the biasing network. You only need the functional block. And then you go back to the schematic here. So let's try if we can drive a circuit like this. So now what I'm going to do is, instead of having the amplifier to drive 50 ohm load directly, I will go through a current driver, the buffer, and see if I can drive it more effectively. So I will connect it direct to here, and then the circuit here will tap the same biasings supply. So the circuit is done. So you simulate the circuit and see if you are lucky. So I don't need this. I simulate the circuit. So you position your cursor in the waveform window and then right click and you choose, and you are going to measure the voltage gain again. So I have not enough, right? There is not enough current. This is the reason why it doesn't work very well. So what I suggest here is, sorry, one thing I forgot. You shouldn't use any capacitor here, because if you have capacitor here, then there will be low DC biasing. We are trying to borrow the voltage here as a biasing voltage. So you need to delete this capacitor. And then you simulate this circuit again. Yeah, very good. So you get 30 dB. It's better than before. Without this bias, without this common collector amplifier as a current driver, you have only 4 dB. But now with this, you get 30 dB. So this is the real purpose of common collector amplifier. It will provide a very decent amount of current. And I can tell you, most likely, with 10 ohm, it will work. Let's try this again. So indeed, even with 10 ohm, it will work. And you can use this circuit uh, to power some heavy electronics, like motor. You can do that. Okay? So if you have any question, please leave your question to the comment sections. Thank you very much. Bye bye.